The 90 degrees Celsius column in Table 310.16 of the National Electrical Code, or NEC, is utilized for determining the ampacity of conductors when they are installed within a raceway or cable system designed to operate at a temperature of 90 degrees Celsius. This configuration is generally implemented in industrial environments where equipment is subjected to significant loads and high ambient temperatures. While the majority of residential and commercial equipment is rated for operation at 75 degrees Celsius, certain instances involve equipment rated for 90 degrees Celsius operation. Examples include specific motors and transformers. In such cases, the 90 degrees Celsius column in Table 310.16 becomes applicable for calculating the ampacity of the conductors supplying the equipment. It is crucial to adhere to the NEC guidelines, which mandate ampacity calculations based on the lower of the two temperature ratings, namely the 75 degrees Celsius or 90 degrees Celsius rating. Consequently, if the equipment's rating is 75 degrees Celsius, the 75 degrees Celsius column in Table 310.16 must be employed for determining conductor ampacity. Consider these scenarios where the 90 degrees Celsius column in Table 310.16 finds its application. Firstly, industrial motors rated for 90 degrees Celsius operation. Secondly, industrial transformers designed for 90 degrees Celsius operation. Thirdly, other industrial equipment with a 90 degrees Celsius rating. Now let's delve deeper into understanding ampacity and its relationship with temperature ratings. Ampacity, in simple terms, is the current carrying capacity of a conductor. It represents the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The temperature rating of a conductor signifies the maximum temperature, in degrees Celsius, that the conductor's insulation can withstand without degradation. The NEC provides ampacity tables, such as Table 310.16, which list the allowable ampacities for various conductor sizes and insulation types at different temperature ratings. These tables are essential for selecting the appropriate conductor size for a particular application. The ampacity of a conductor is influenced by several factors, including the conductor's size, insulation type, installation method, and ambient temperature. Larger conductors have a greater surface area for heat dissipation and can therefore carry more current. Different insulation types have varying temperature ratings, which affect the conductor's ampacity. The installation method, such as whether the conductor is installed in a raceway or free air, also affects its ability to dissipate heat. The ambient temperature, which is the temperature of the surrounding environment, can also impact the conductor's ampacity. When the ambient temperature is high, the conductor's ampacity is reduced. The NEC provides correction factors for adjusting ampacity based on ambient temperature. Now let's focus on the practical application of Table 310.16. When selecting a conductor for a specific application, it is crucial to consider the equipment's temperature rating and the ambient temperature. If the equipment is rated for 75 degrees Celsius operation, the 75 degrees Celsius column in Table 310.16 should be used to determine the conductor's ampacity. However, if the equipment is rated for 90 degrees Celsius operation, the 90 degrees Celsius column can be used, provided that all other conditions are met. It is important to note that the NEC requires the use of the lower of the two temperature ratings when calculating ampacity. This is a safety measure to ensure that the conductor's insulation does not overheat and degrade, which could lead to a fire or other electrical hazards. Let's illustrate this with an example. Suppose you are installing a conductor to supply power to a motor that is rated for 75 degrees Celsius operation. The ambient temperature is 30 degrees Celsius. According to Table 310.16, a 12 American wire gauge, or OLG, copper conductor with THHN insulation has an ampacity of 30 amps at 75 degrees Celsius. Therefore, a 12 AWG conductor would be suitable for this application, provided that the motor's full load current does not exceed 30 amps. However, if the motor were rated for 90 degrees Celsius operation, you could potentially use a smaller conductor. According to Table 310.16, a 14 AWG copper conductor with THHN insulation has an ampacity of 25 amps at 90 degrees Celsius. Therefore, a 14 AWG conductor could be used in this case, provided that the motor's full load current does not exceed 25 amps and that all other conditions are met. It is important to consult the NEC for specific requirements and ampacity correction factors. The NEC provides detailed guidelines for calculating ampacity under various conditions. It is also important to consult with a qualified electrical engineer or electrician to ensure that the electrical installation meets all applicable codes and standards. In summary, the 90 degrees Celsius column in Table 310.16 of the NEC is used for calculating the ampacity of conductors that are installed in a raceway or cable system operating at 90 degrees Celsius. This is typically used for industrial applications where equipment is operating under heavy loads and the ambient temperature is high. While most residential and commercial equipment is rated for operation at 75 degrees Celsius, some equipment, such as certain motors and transformers, may be rated for 90 degrees Celsius operation. In these cases, the 90 degrees Celsius column in Table 310.16 can be used to calculate the ampacity of the conductors that are used to supply the equipment. It is important to note that the NEC requires that the ampacity of conductors be calculated using the lower of the two ratings, that is the 75 degrees Celsius rating or the 90 degrees Celsius rating. This means that if the equipment is rated for operation at 75 degrees Celsius, then the 75 degrees Celsius column in Table 310.16 must be used to calculate the ampacity of the conductors. The selection of appropriate conductor sizes, consideration of ambient temperature, and adherence to NEC guidelines are crucial for ensuring electrical safety and preventing potential hazards. Consulting with qualified professionals is recommended to ensure compliance with all applicable codes and standards. Let's consider some additional aspects related to the application of the 90 degrees Celsius column in Table 310.16. Firstly, it's essential to understand the types of insulation that are rated for 90 degrees Celsius operation. Common examples include THHN, THHW, and XHHW insulation. These insulation types are designed to withstand higher temperatures compared to those rated for 75 degrees Celsius. Secondly, when using the 90 degrees Celsius column, it's crucial to ensure that all components in the electrical system are also rated for 90 degrees Celsius operation. This includes the terminals, connectors, and other devices that the conductors are connected to. Using components with lower temperature ratings can compromise the safety and reliability of the system. Thirdly, the NEC provides specific requirements for dirting conductors when multiple conductors are installed in a raceway or cable. These dirting factors reduce the allowable ampacity of the conductors to prevent overheating. When using the 90 degrees Celsius column, it's essential to apply the appropriate dirting factors based on the number of conductors and the ambient temperature. Fourthly, it's important to consider the voltage drop in the conductors. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in electrical systems. When using the 90 degrees Celsius column, it's important to ensure that the voltage drop in the conductors does not exceed the allowable limits. Fifthly, regular inspection and maintenance of electrical systems are crucial for ensuring their continued safety and reliability. This includes checking conductors for signs of damage or overheating, tightening connections, and testing the insulation resistance. When using the 90 degrees Celsius column, it's especially important to pay attention to the condition of the conductors and insulation, as they are operating at higher temperatures. Let's now explore some specific scenarios where the 90 degrees Celsius column might be applicable. One example is in data centers, where high-density equipment generates a significant amount of heat. In these environments, it may be necessary to use conductors with 90 degrees Celsius insulation to handle the higher operating temperatures. Another example is in industrial facilities with heavy machinery and equipment. These facilities often have high ambient temperatures and may require the use of 90 degrees Celsius conductors to ensure reliable operation. A further example is in renewable energy systems such as solar and wind power installations. These systems often operate in harsh environments and may require conductors with high temperature ratings to withstand the extreme conditions. In addition to these specific scenarios, the 90°C column may also be applicable in other situations where conductors are exposed to high temperatures or heavy loads. It's important to carefully evaluate the operating conditions and consult the NEC to determine the appropriate conductor size and insulation type. Let's delve into some best practices for working with 90°C conductors. Firstly, always use the correct tools and equipment when installing and terminating conductors. This includes using insulated tools, torque wrenches, and other specialized tools designed for working with electrical conductors. Secondly, follow the manufacturer's instructions for installing and terminating conductors. This will ensure that the connections are properly made and that the conductors are not damaged. Thirdly, always wear appropriate personal protective equipment, or PPE, when working with electrical conductors. This includes safety glasses, gloves, and other protective gear. Fourthly, never work on energized electrical circuits unless you are qualified and authorized to do so. If you must work on energized circuits, always follow safe work practices and use appropriate PPE. Fifthly, if you are not comfortable working with electrical conductors, always hire a qualified electrician to do the work. Electrical work can be dangerous, and it's important to ensure that it is done safely and correctly. Let's consider some common mistakes to avoid when working with 90°C conductors. One common mistake is using the wrong size conductor for the application. This can lead to overheating and potential fire hazards. Another common mistake is using the wrong type of insulation for the application. This can cause the insulation to degrade and fail, leading to electrical shorts and other problems. A further common mistake is not properly terminating the conductors. This can cause loose connections, which can lead to overheating and potential fire hazards. In addition to these common mistakes, it's also important to avoid over-tightening connections, damaging the insulation, and exceeding the conductor's ampacity rating. By avoiding these mistakes, you can help ensure the safety and reliability of electrical systems. In conclusion, understanding the proper application of the 90°C column in Table 310.16 of the NEC is crucial for ensuring the safety and reliability of electrical systems. By considering the equipment's temperature rating, ambient temperature, and other relevant factors, you can select the appropriate conductor size and insulation type for the application. Remember to always consult the NEC and other applicable codes and standards, and to seek guidance from qualified professionals when needed. The NEC is a comprehensive set of standards that provides detailed requirements for electrical installations. It is updated every 3 years to reflect the latest advances in technology and safety practices. Familiarity with the NEC is essential for anyone involved in electrical work. In addition to the NEC, there are other relevant codes and standards that may apply to electrical installations. These include local building codes, fire codes, and industry standards. It's important to be aware of all applicable codes and standards and to ensure that electrical installations comply with all requirements. Continuing education is also crucial for staying up to date with the latest advances in electrical technology and safety practices. There are many opportunities for continuing education, including courses, seminars, and online resources. By investing in continuing education, you can enhance your knowledge and skills and improve your ability to perform electrical work safely and effectively. Safety should always be the top priority when working with electrical systems. Electrical hazards can cause serious injuries or even death. It's important to follow safe work practices, use appropriate PPE, and be aware of potential hazards. By prioritizing safety, you can help protect yourself and others from electrical injuries. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or electrician before performing any electrical work. Electrical work can be dangerous, and it's important to ensure that it is done safely and correctly. By following these guidelines and seeking professional guidance when needed, you can help ensure the safety and reliability of electrical systems. Remember that the 90°C column in Table 310.16 is a valuable tool for calculating conductor ampacity in certain situations, but it's essential to use it correctly and to follow all applicable codes and standards.